Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video I am going to discuss how we can easily develop a Kafka consumer monitoring system using Python. Okay, so whenever we talk about Kafka consumer monitoring, then one of the major important parameter is consumer lag. Related to this, I have already discussed in detail in my previous video. I'll be sharing the link in the description box. If you want, you can go through that. In short, the consumer lag is nothing but the difference between the last offset stored by the broker and the last committed offset for that particular partition within a topic. What is the difference between these two? That is what the last offset stored by broker and the last offset committed by the consumer. In between that, whatever difference is there for any particular partition within a topic, that is nothing but called as consumer lag, right? Now we need to build a system where using Python we will continuously monitor consumer lag and then we will send alert when the consumer lag will increase, because the increase in consumer lag is not a good situation. That means our throughput in which the messages are getting produced, that is much higher than the consumer throughput or the rate in which the messages are getting consumed, right? Ideally in real time world we should have almost same consumption rate as of production rate, but when these two mismatch happens and the production rate increases and the consumer rate cannot cope up with that same level, then the lag started getting increased, which is not an healthy situation. So we should have some alert mechanism to monitor this continuously. So what we can do, we can basically schedule a job using Airflow, and in that Airflow we can run our Python code which can detect this consumer lag for a particular Kafka topic within all the partitions, and when the consumer lag will increase a certain value, we can send alert, right? So this is a very simple architecture what is shown here. Now without any further delay, let me show you the Python code implementation. Because Airflow code writing is very simple, the main important thing is how using Python we can calculate the consumer lag, right? So here we are having some codes. Let's go through that. So here first we are having Kafka producer. This particular code I have already explained multiple times. We are importing all the necessary modules. We are having a topic called Hello World 1, and then here custom partitioner we have created, and this is our producer object. Here we need to provide the Kafka server or broker URL. Here in this variable we need to put, and serializer and the partition in which the data will be written, that partition algorithm we are mentioning as custom partitioner. Okay, what we are doing here in custom partitioner, basically the key part we are dividing by total number of partition, and based on remainder value we are ingesting the data in appropriate partition. For example, if after dividing by total number of partition, if we are getting the remainder value as 1, then the message should go to partition 1. If we are getting 0, the message should go to partition 0, like that and so on, right? Here what we are doing, we are iterating 1000 times using a for loop. We are generating some sample data and we are publishing those data using producer.set, right? And in between each message published, there is a 0.4 second delay or sleep time we have kept. Now here let's go to our consumer side. What we are doing in the consumer side, here it is common like earlier also we discussed, imported all the necessary modules, created the consumer. Here the topic name we can basically put same. Here in consumer side also Hello World 1, and in the producer side also Hello World 1, right? And then here we have created our consumer. Here using a for loop we are consuming the messages, but in between each message consumption we are giving a 0.8 second sleep time. Okay, so here from this sleep interval itself you can understand that the producer message publish rate will be much higher compared to the consumer message consumption rate, because here for per message we are giving 0.8 second sleep, but here in producer we are giving only 0.4 second sleep in between two message publish events, right? So obviously producer side the message generation rate is much higher than the consumption. Now suppose we want to calculate at a certain point of time what is the consumer lag, that is what is the difference between the last offset stored by the broker and the last committed offset for a particular partition. So for that this is the code which we can go through step by step. So for this particular discussion of the code, first what I will do, I will quickly start or launch our Kafka cluster in an EC2 instance, and we will parallelly execute the code to understand it in a better way. Okay, so here I will go to instance, and here I can launch an instance, and here EC2 Kafka I can put, and here I am choosing a Linux environment and keeping T2 micro, that is fine. And here I am having one particular key value pair, and then I can allow as of now all this, and keeping all other properties unchanged, we can launch the instance. Okay, and then we need to update the security also. I'll go to security group, I'll click on here edit inbound rule, and then here all traffic allow all IPv4 access. Okay, we'll save this. I'll go to EC2 instance running. So currently here this particular instance started running, right? So I'll just copy this and then we'll use putty to log in it. Okay, I'll browse and choose my APK file. I'll change this setting to avoid timeout and log in as EC2 user. Okay, and then here first I will download Kafka. All the comments I'll be putting in the description box or in the comment section so that you can parallelly practice it. I'll unzip that, and for running Kafka we need Java also, so I am installing Java, and then here we need to change one property so that the server will be accessible from the public IP of EC2, and that is advertise listener. So once Java is installed, I will update that. So here I will go to server properties, and here I will go to advertise listener. And here I'll copy the public IP and paste it. So it is updated. Now if we start running our Kafka Zookeeper or Kafka Broker, it will run in the public IP. Okay, so here I need to put one more point, that is start Zookeeper. Okay, first we'll start the Zookeeper. So first I need to go to this CD, is this directory, and then if you do ls, here all the important folders are available. Now we need to execute this particular command to start the Zookeeper. So here if you see, our Zookeeper is started. I will duplicate this particular session and log in as EC2 user, and then here I will start my Kafka server. But here first we need to configure such that the memory limit will not be exceeded. So this particular export command will execute first, and then here what we'll do, we'll go to this directory and start our Kafka server. Okay, and once this server gets started, what we need to do, we need to create a topic. The topic name we can give hello world 1 as of now, and I'll copy the public IP of EC2, and then here booster server I will take, and 3 partitions I am creating. So I am duplicating the session and log in as EC2 user, and then here first we need to go to that directory. So I will copy both the codes, and then here I'll execute. So here the topic got successfully created. Okay, I'll copy the public IP also, and I'll put in all my codes. I need to provide the port number. If you want to make sure what is the port number, you can go to the local logs, and here you can see that it is running in 54.211.184.11:9092, right? So here I will keep that. And this is our Kafka server. I'll update in my consumer script also and the log printer script also. Okay, what I will do first in this particular code, I'll explain step by step. First I have commented out all this. Let's focus on only this particular part. Okay, what we are doing, that ultimate goal is calculation of consumer lag partition wise, right? So as a first step, we should know how many partitions are there for a particular topic for which we want to compute the consumer lag. So in this case, the topic name is hello world. In this update, and here what we are doing, the topic name is hello world, and whenever we are calculating consumer lag, it is basically for a particular consumer group. So the group ID we need to provide. So for this particular consumer, the group ID is having the same name as of topic. So same thing we are configuring here. And then the Kafka server or broker URL we have kept. We have created the consumer, and then here we are having a method partitions for topic. So what it does, it basically returns us how many partitions are there for a particular topic, and their IDs it basically return. If you want, you can copy this and go to the documentation, just search it here, and here you can clearly see this method first check local metadata cache for information about the topic. If the topic is not found, then it will issue a metadata update call to the cluster, and ultimately it return all the partition IDs for a particular topic. Okay, so as a first step, we should get the partition IDs, then only for individual partition ID we can do further analysis to compute the consumer lag. Okay, so here as a first step, what I will do, I will start my consumer. So here I have started my consumer. Currently it is consuming no message because the producer has not produced any message. So what I will do, I will start my producer also. Okay, so here you can see producer has published some messages, and here consumer is consuming also. Now this run I am just doing just to show you the code of log printer. I'll just pause the consumer and pause the producer also. Now let's go to the log printer code. So let's focus on up to only this particular part. We will run the code and we'll see whether for hello world 1 it is printing the proper partition IDs or not. So for this particular topic hello world 1, if you see the topic generation code, here we have configured partition 3. That means for this particular topic there are 3 partitions. The partition ID should be 0, 1 and 2. So let's run this particular code and see whether it is printing or not. So here you can see it is printing 0, 1 and 2. That means automatically using partition for topic we can easily capture for a particular topic what are the partition IDs available. Now let's go to the next part of the code. Okay, this is again very important part. I'll just uncomment this. What we are doing here. So to compute the consumer lag, we should know 2 things. Number 1, what is the last offset committed by consumer, and another one is what is the last offset stored by the broker. Okay, to understand the last offset stored by the broker, that is whatever message the producer has produced for a particular topic within a partition, what is the last offset for the production of message? For that there is a method called end offset. So if you just put your mouse pointer over that, here it is clearly showing what it does. It basically get the last offset for a given partition. Okay, so consumer already we have created, right, this particular one, and then we can just call the method using dot end offset. But what we need to pass? We need to pass a very important thing. That is basically topic partition object. Okay, here you can see the parameter. The parameter is list of topic partition instances to fetch offset for. Okay, so in different partitions, the producer has published messages and it is having the last offset stored. Now if you want to know what is the last offset stored by the broker for individual partitions, for that you should pass the input parameter in end offsets properly. And how you should pass? You should pass it as topic partition. And how we can create the topic partition instance? It is nothing but we can iterate in partitions dictionary. So here this is nothing but a set, right? So it is partition IDs. So we are iterating in partition IDs and we are creating the topic partition object or instance. We have imported already topic partition here. If you see that from Kafka import topic partition, if you want to know the implementation of it, just click on this and here you can see it is a named tuple. Okay, it is expecting 2 things. One is topic, one is partition. So here we are doing that. We are passing the topic name. The topic name basically is configured in this particular variable, and the partition it is getting from this iteration. Okay, that way we are creating the array for topic partition name tuple. Okay, and all the name tuple we are passing in the end offsets, right? And once we pass that, we can easily get for individual topic partition what is the last offset committed by the broker or the producer. Okay, so let me run this and you will understand this. So I will just run it again, and here you will see that it is printing the topic partition and the offset what is stored by the broker. So see the first point, topic partition, the topic name and the partition 0. For this, the last offset what is stored by the broker, that is basically up to this offset, the producer has produced the message, that is 13. For the partition 1 also it is 13, and for the partition 2 if you go, it is also 13. Okay, all 13, 13, 13. That means in all the partitions, the broker has committed the offset up to 13. If you want to double confirm using shell script, that also you can do. Let me show you that. So here we are having basically this particular command, consumer group description. So here I will just update the server URL and the group name we need to pass for which we want to do analysis. So in this case, the group name is same as topic name, that is hello world 1, and then we can use describe command to get all the details for a particular consumer group. So if we run this, here you will see the log end offset. This particular column is basically showing till what offset the broker has stored. That is basically meaning till what offset the producer has produced the message for different partitions. So here you can see for partition 0 also 13, for partition 1 also 13, for partition 2 also 13. And here our this particular Python code is also returning 13, 13, and here for this particular partition 2 also it is 13, right? So that means we got one part for calculation of consumer lag. That is till what offset the broker has stored for a particular partition, right? Now we should know for a particular partition till what level the consumer has consumed. That is consumer commit offset that we need to compute for individual partition level. Then only we can make the difference and get the consumer lag. So for that we are having this particular code. Okay. So let's try to understand what this code is doing. So first here we are iterating for I in TP. TP is nothing but topic partition. Okay. This is basically one array where individual object is nothing but topic partition. And here we are basically now computing consumer committed offset individual partition level. So for that we are having another method called consumer.committed. So here if you see the documentation, there is something called committed method. It basically returns us the last committed offset for a given partition by a consumer within a consumer group. So here what we need to do, we need to again pass the topic partition. If you see the documentation there itself, it is clearly written. The parameter is the partition to check, and it should be topic partition. It is not the simple partition ID, right? So here what we are doing, we are iterating in topic partition array, and we are passing one particular topic partition object at a particular point of time just to get the last committed offset. Okay. Now it might happen that the consumer has not started consumption of message from that particular partition. So that time this will return none. Okay. Or if the consumer has committed some offset for that partition, it will return that value. So that's why I have written it in a if else condition. If this particular thing is returning none, then I am putting 0. That means the consumer has not started consumption of message from that particular partition within the topic for that consumer, right? Or else if this is not none, then we are simply returning the value whatever it is basically fetching from the Kafka cluster. Okay, so I hope this particular part is clear to you. We basically calculated what is the last committed offset for that particular consumer within that particular partition. Okay, now in this particular topic partition last offset, what we got, this is basically nothing but a dictionary, and here the dictionary key is nothing but our topic partition instance, and here the value part is nothing but till what offset the broker has stored the message information. Now we need to compare, right? So for that what we are doing, here we are extracting from this particular dictionary whatever we got here, from there the last offset stored by the broker that we are getting. So here I can rename the variable last offset stored by broker in partition. Okay, to extract this we are basically referring this particular dictionary, and whenever we need to extract the value part for a particular key in a dictionary, what we need to do, we need to pass the key in the dictionary, right? So that same way we are following here. The key is basically topic partition object, so that we are passing here. That way we are getting the last offset stored by the broker in a partition, and now we have the consumer committed offset and the last offset stored by the broker in partition. We can simply subtract those two to get the lag, right? And here we are printing the topic name, the partition, okay, and here the consumer committed offset, last offset, and the lag is basically the difference value in between consumer committed offset and the last offset. Obviously last offset is greater than or at least equal to the consumer committed offset. Consumer committed offset can never go beyond last offset, because last offset is nothing but up to where the producer has produced the message for that partition. The commit offset cannot go beyond that, right? So this is how we are printing it. Now let me run it just to show you how it is working. I'll just run this, and here you will see that first it printed all the partition IDs, then it has basically printed for individual partition what is the last offset stored by broker, and here we got some error name last offset. I think we renamed a variable, that's why it is throwing an error. Here I will just update it. Here is your last offset. It is basically last offset stored by the broker. Okay, right? So let me just run it. And here you can see it has printed 3 things. So for this topic hello world 1, within this partition 0, for this particular consumer group, right, we are having the consumer, and the consumer is consuming the message from all the partitions, and what is the lag? It is clearly showing. Current consumer offset for the partition 0 is 3, okay, whereas the last offset is 13. So 13 minus 3, the lag is 10. So for partition 1, the current consumer offset up to which the consumer has consumed the message, it is 7. But the last offset stored by the broker is 13, so lag is 6. Similarly, in this case, the lag is 10. So 10, 6, 10. Let's see whether it is matching with our shell script or not. If I just scroll and keep this particular shell script here, you can see the lag for partition 0 is 10, matching with our Python code. For partition 1 is 6, and for partition 2 is 10. That means whatever this particular shell script we were using for monitoring consumer lag, that the same thing our Python code is also giving. Now the Python code we can easily schedule using Airflow, and we can set up some alert using a if-else condition that if the lag is increasing a certain value, then alert the developer team or production support team to monitor what happened, why the consumer is not able to consume in same speed and the lag is continuously increasing, right? So I will just run it again to show you at any point of time it will give correct result only. So here the producer started producing messages, and here I am starting the consumer after some time. See, consumer is consuming the message. The rate is very slow because here sleep time is high. Maybe I can launch another consumer. So here the replica code I have created, I can just update the topic name, group ID, or I can maybe copy the same code here. Kafka will do that consumer group rebalancing, and it will assign some new partition to this, and it will revoke some partition from this particular consumer, right? So here the consumer 4 is consuming from partition 2, the consumer 2 is also consuming, the producer is continuously producing at high speed. I'll pause this, all these things, and then let's calculate the lag. Okay. In production system, we don't need to stop anything to monitor the lag. This is just I am going to show you the shell script and the Python code is returning the same result. Okay. So here if you see, this is the output what our shell script is giving. So for partition 0, the lag is 51. Here also our Python code is printing lag is 51. For partition 1, the lag is 39. Here also it is printing 39. For partition 2, it is 36. Here also it is printing 36. That means this log printer is perfectly working, right? So I hope you understood this particular code. Now this code you can easily schedule using Airflow and set up the Kafka Consumer Monitoring System easily. The code I'll be providing in the description box or in the comment section. If you want, you can just launch an Kafka cluster and try to play with this particular code to have some better idea. So this is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.